Hello and welcome to lesson 3 in our introduction to programming microcontrollers, in which we're going to continue looking at how we can code LEDs. So as I've previously talked about, we're going to be looking at basic programming constructs, which is sequence, iteration and selection. And once we can get our head around doing those three things, we can pretty much do anything we need. And to do that, we're going to look at obviously NeoPixel servos, motor controls, ultrasonics, maybe going as far as MP3 players, and looking at how we can use Wi-Fi and Bluetooth to control our devices. So I said all programming languages pretty much have the same core concept as input and output, sequence, selection, repetition. And then last lesson we looked at output, which was where we were flashing an LED on and off. We also looked at sequence, at how we could flash a sequence of LEDs on and off, going from pin 13 down to pin 9 I think it was. And then this lesson we are going to look at some basic repetition, so how we can repeat our code to make things, well, to improve our sequences. So looking at that, before I go into this next little bit, data types. Now we had a brief look at this last lesson in which we looked at this timer. This is us creating a variable. We created a variable called timer and we stored the value 100 into it, so that we didn't have to keep saying what time this was going to be every time I wanted to turn something on and off. So we didn't have to keep writing 100. Even if I want to speed it up, I could just change to 500 and I don't have to go through all the other things. So that was us creating a variable. Now when we create variables, we should sort of say what data type do we want. So in this case, in programming languages like C++, C#, Java, we do have to declare them. In languages like Python, we don't have to, but we'll come to that much later on. So a Boolean data type is true or false, on or off. Is it there? Is it not there? Simple as that. Integer, working with just whole numbers. Real, they're numbers where you have a decimal point. And a string, that's where you just want to work with text or other symbols. There are lots of others, and I'm not going to go through all these. I've just mentioned the ones that we will mainly use. And again, I'll explain these as we need them in the code. But what I do want to focus on in this session is iteration. Again, this is where we can repeat lines of code over and over again. This is what computers are really good at. So if we were to just nip back into our code from last lesson, there we go, we've got this void loop. So loop is another word for iteration, and this little thing will loop over and over while ever the chip is turned on. So let's have a look at some different kind of loops. We've basically got three kinds. There are others, but they're just variations of these three, and that is a for loop, a do loop and a while loop. So a for loop is a counted loop. It's going to repeat this through this list or whatever it is a certain amount of times. So if you say for 1 equals 1 to 10, it will do that same block of code 10 times. A do loop is it will do this block of code and then it'll repeat it again until something happens. So it always runs once. A while loop, while something is true, repeat this block of code. So it may never run, or it could run forever. And that's exactly what this bit of code is doing here. This is a while loop. While it's got power, run this code, and it won't ever stop until either A crashes in a big way or you turn your chip off. Okay, so let's sort of move into this code, into our next little bit of programming. So obviously last lesson we took a look at this. We set our pin mode up and we told each of these pins, pin 13, 12, 11, 10 and 9, to be outputs, so that the Arduino library and our actual thing in front of us, it knows that these pins, these sockets are going to be used for output. And that can be a problem, because if you forget to do this, it might not work properly. So we remember what we did. I had the ground connected to the what do we call it? So I always forget these little bits. To the, what was going to tell me? It's not, to the cathode of the LEDs, which then goes through the resistor and then came back to the actual pins we are connected to. So I'm going to leave that bit of code as it is. I could make that a bit shorter, but there's not much point at this time. What I'm going to do is go into this loop here. Now I does write all of this out. I don't really need to do that. In fact, you can't see that bottom bit, I might turn me off in a moment. So what we did was we had all of this sort of to go counting down. We can see it's going 13, 12, 11, 10, 9. Then finally it goes again 13, 12, 11. I can just delete all of that. Don't want it, but I can do something a little bit quicker. So, like I said earlier, I'm going to create an integer called LED. Now, just to make this a little bit easier, I'm going to start at our lowest numbered LED, which is 9. So I'm just going to int LED equals 9. So what I can do is just say LED. So now we've got this integer called LED, and it's going to write to that LED number 9. High. It's going to turn LED 9 high. So if I was to now turn this on, just try it, pressing start. Oops, we've got a bit of a mistake because I've made a silly error. In C++, C#, Java, JavaScript, PHP, we have to end every line with a semicolon. That's a really common mistake to make. So let's just try that again. There we go, we've turned LED 9 on, but then it just stops. So it's sat in that forever loop. You know, it's not going to do anything else now. So what I'm going to do is create a for loop. So the logic is we can start with one number, go to another, and then it'll end. So I'm going to go for, and this is where I open my brackets, my parentheses. Again, this grammar is important. If you miss one out, it will mess up. And I'm just going to go int I equals, now for some reason we always use I. Just like in maths, when you use x and y for coordinates, we always use I for doing loops. You don't have to, we're just going to. So if I say I equals, now normally I go straight to 0, but I'm not, I'm going to go 9. So really I didn't actually need to do that. What I should do is this, LED. So while LED equals 9, semicolon. Again, this grammar, very important. So for int LED equals 9, so it starts at 9, LED less than or equal to 13, because we're going to go from 9, 10, 11, 12, 13. So it's going to go up to 13. The reason why I did the less than sign is because we normally do up to the lowest number, which is less than 13, but that means it won't actually go to 13, it'll stop before it gets there. But I'll prove that in a moment. So if I go LED plus plus. So basically, we're going to start at 9, and while LED is less than 13, we're going to add 1 to it, and we're going to turn the LED on. Now I need one more bracket. Sorry, in this case, it's a curly bracket. It's a brace. I'm going to come down there and put one there. Now, for good programming standards, I'm going to indent these, because I always like to see the starting and the end. And now if I press start, now if you've coded in Python, you'll know that indentation is compulsory. Okay, so I'm just going to change the variable to just 100 so it's a bit quicker, and we'll be able to see that it's going to go 9, 10, 11, 12, and it's going to stop. So if I press play, there we go, it's done 9, 10, 11, 12, it stopped. So I'm just going to fix that by just saying less than or equal to 13, so it will go up to 13 as well. Okay, there we go, we can see it lighting up. So if we had 5 LEDs, obviously we've got 5 times. Now if we'd suddenly got a whole lot more, let's say we'd got, I don't know, 140 LEDs, which is not unreasonable in some projects, it's so much quicker to just go, you know, from LED 1 to LED 250, and it would turn them all on in sequence. Obviously I don't have that many hooked up, so I'll put it back. So now if I want to make them turn off, I can do the reverse. I can go copy, paste, and now I'm just going to say LED equals 13, while LED is greater than or equal to 9, LED minus minus. By the way, if you're not sure, the plus plus just means add 1 to it, minus minus means take 1 away from it. And now I can just put this to low. So now what we should see is this just repeating. There we go. Now this looks nicer on a real board, by the way, and I'll show you that in a moment on an actual board. Now what it's also doing is it's stalling a little bit because we are turning things on off, so we can optimize this a little bit. Rather than going to 13, we could actually stop these. Yeah, because it's actually hanging on the first LED and the last LED. I could actually just turn this off. I could say let's start at 12 instead, but right here without a delay I could just turn the LED off. I could just turn LED, oops, too far. I could just say let's turn LED 13 off straight away without a delay, so it might look a little bit smoother. This is where you can have a bit of fun with coding. There we go, that looks a little bit smoother, isn't it? It's straight there rather than holding on the last LED. Now the browser's not very happy. This is where the browser is not great at this sort of thing. It is much better for real. So let's take a little look at it for real. So I've already created an LED board. You know, I've got the Arduino. Hold on, just focus that. There we go. So I've already got the Arduino. I've done the jumper wires. I'm very good at this, am I? It's got the jumper wires going into the LEDs and the resistors the exact same way that we've got in the background. You know, it's the exact same wiring. The only thing the difference is is that I've just put the LEDs on the other side of the breadboard, because I did this a while ago, actually before I did this on screen. So what I can now do is, if I just plug this, so I just plug that in. Now right now this is running, it's just running the blink test. So it's still running the blink code. So I'm going to show you how we can copy that across. So if I just grab this bit of code, I'm going to copy. I'm going to go over to Arduino itself. I've already got a blank file made. I did have the blink code loaded up just so I could reset the original Arduino. So I'm in Arduino IDE. I'm going to copy and paste that from there into here. So there we go. We can see I've copied it over. I'm going to go on to Tools. Make sure that I've got the board selected properly. So I've got the Arduino Uno, which is what I've got plugged in. I'm going to check on port. It's saying just COM port 1, which I'm a bit concerned about. I should be able to see the other port. There we go. I've just plugged the wire in properly. So I'm going to go on Tools, Port. There we go. It's now on COM 8. It's automatically ticked it for me. It might not do that for you, so do make sure you have selected it. So now when I press play, it's going to compile that code. And then once it's finished compiling, it will copy it across. There we go, we can see it's copied across now. So now we can see our nice little sequence of LEDs working as it should. So you can see it's really easy to jump between the Tinkercad interface and Arduino IDE for the exact same results. Yes, for real, it is always nicer, but Tinkercad is safer and quicker, and you can do it on your phone and a tablet, etc. So to summarise, we've got the while loop running here. We don't have to tell it it's a while loop. It just is one, so we don't have to change anything about that. And then we've used these two for loops, these counted loops, to count up and down. And of course what I encourage you to do is pause the video here and go and have a play. Okay, one of my other main reasons for liking teaching programming with Arduinos is the fact that we can add a tiny little speaker sort of. So just underneath the circuit board, I've got this little piezo buzzer. I've also got it on this little board just here. You can see it sort of sat, you can see it just sort of sat underneath the orange cable. And this is another great way for sort of learning about how we can do for loops and iteration. So we're going to go into this code, into our Tinkercad, and I'm going to add a piezo buzzer. So I'm going to hide the code for the moment. I'm going to find a piezo buzzer, which I can never quite spell, so I hope it's going to help me. Yep, there it is, that's good. This is a great way to add the little sort of 1980s style sound effects to your device, to your robots or whatever other things you're working on. So we can see it's got a simple positive and a minus. So I'm going to drag a little cable to our ground, and then I'm going to drag, I'm just going to use pin 7. Doesn't matter which pin you use, but I'm just going to use pin 7. That's going to come all the way along. I'm just going to click that to it, and I'll change that. It's up to you what colour schemes you go with. I'm just going to make it orange so it just contrasts with the others. So now I've got this little buzzer. So I'm going to open the code again. We're going to need another pin mode output. So if I just go pin mode 7 is output. Now again, this is where I should really start naming things. I should start using variables to keep control of the pins. So if I do swap it, I change one little bit. So I think I shall do that now. Which I'm going to go is, I'm going to define up here. So I'm going to start with a hash, define, oops, spelled that wrong, speaker, and then I'm just going to, what is that? Just put that on pin 7. So I don't need to end this line with a semicolon, by the way. So now I'm going to say my speaker is on pin 7, so I'm just going to put speaker. And this basically what this means is if I do decide to rewire this circuit board, I don't need to go back all through my code. I can, if I move the wires around, I can just simply move the wires as I want, or if I was then converting it to something like this, and then I can just simply change this number up here and everything else would work just fine. So I've got the speaker output. I can leave this sequence in here, but what I will do at the very beginning, in fact in our setup function, so as I mentioned previous lesson setup, this runs just once, this is not part of a loop. So if I come down here, I can now go tone. So tone is a function built into Arduino IDE. It's going to do all stuff behind the scenes for us. I'm going to say speaker, I'm going to say 1000, and what that's going to do is it's going to create me a pitch at about 1000 hertz, is it? I don't know, I'll have a look in a moment, I'll try and remember that, what it is. And then I'm going to do a delay. So that delay is going to be, again, 1000. Now, again, this is something that works much better on the real piezo buzzer. On the Tinkercad, it doesn't sound quite as good. So let's have a little run of that. We should be able to hear it. Now, that didn't run for a second, that kept on going. By the way, warning, if you do this in a class full of people, this gets really irritating. What I actually need to do is make sure I turn it off. So I'm just going to go no tone. So no tone obviously means turn the piezo buzzer off, otherwise it will stay on forever. So this is an important one to make sure you include and don't forget it, otherwise it will become extremely irritating. So now when I press start, okay, it did not stop. Why not? Okay, I just thought I'd better stop it there quickly to check why it wasn't working. If I press start again, it does stop. Again, it's just the browser is not honouring our timings. I did add a delay 250 there, so it would delay for 1/4 of a second to see if it makes a difference. But obviously it's just going on a bit longer than it should. On the real system, that would be just fine. So again, coming to our loops, and what I'm going to do now, and this is the bit that I really like about doing with Arduinos, and it's the sort of stuff that some of us kids would have done, for those who were in the 80s, kids that would have done our computers, but modern day computers don't tend to let us do this, and that's make silly little tunes like you might hear in a game. So if I go and just click right here, I'm going to go for int I equals 0, I less than, gone to capitals there, I less than 5,000, I plus plus, close brackets, making sure I've done everything right. Yep, I have, that's fine. So I'm putting my opening and closing brace in, and now I can use the tone command. So tone, speaker, comma, forgot my semicolon, again, very important. And then I'm just going to put delay 10. So what that's going to do is it's going to start at 0, and every 10 milliseconds it's going to go up by 1 note. Now again, we've already proved that in Tinkercad it sometimes struggles a little bit with real-time things, but let's have a go. Okay, I think we get the pitch there. Feel free to let it go all the way. I'm going to bring this down to just 2,500, but I'm sure 5,000 is about where it's at. If you're not sure what these are the hertz. So I think if I just put 440 in, that should be approximately A. I think that's correct. We might just need to look up a table. To speed this up a little bit, rather than going plus plus for plus equals 1, adding 1 to I can go plus equals 10. So it's going to go 0, 10, 20, 30, and so on. I could even reduce the delay a little bit to make it go a little bit faster. So let's have a listen to that. And again, some of you might now be familiar with, if you've been to the seaside and there's machines playing and grabber machines and slot machines, this is pretty much how they do those sound effects. So inside those slot machines may just be a little Arduino sat there making the noises. So if you notice, I've just copied that code. What I'm going to do now is go to the 2,500. So I'm going to start at the note we just got to, but this time I'm now going to go while it's greater than, let's just say 100 for now. I don't need to go all the way down. Minus equals, let's say 50. And this time I'm going to put a delay of 25. And I'm going to see if I can bear going through the whole thing. So yeah, we heard it going spiraling up and spiraling down. So what I would suggest is have a good play with this. Play with the numbers. Do different for loops. Do loops within loops. There's all sorts you could do. For example, if I was just to, as it's counting up, I could do another note. I could go tone. I don't know if this is going to work very well or not. I could just go, speaker, tone, and I'm going to say 150. I'm not sure what note that is. I'm just going to put another delay of 5 in. I've messed that up. Clumsy copying and pasting there. And let's see what sort of horrible noise this makes. Nope, got a mistake. What did I do wrong? I forgot to put a comma between the speaker. I think that's when I did my clumsy typing. Again, please feel free to play. This can get very irritating and fun all at once. Okay, so we're going to have a look now on the real thing. So again, you can see I've got the actual piezo. It's wired in the exact same way that I've done in Tinkercad. The positive, The main thing to do is make sure you look at the positive symbol on the piezo and get it the right way around. You'll not damage it, it just won't work. Okay, so just like before, I'm going to be lazy. I'm going to grab this bit of code because, yep, I don't like typing on camera. So if I jump into Tinkercad, let's just do that. Let's do that. So if I just go define speaker 7, because I've plugged in the exact same pin. And the only reason I'm really copying and pasting it is to show you that this is how interchangeable it is, provided it's all set up properly. Obviously that's not very neat. And now I can copy this bit of code across, put it before we flash the lights. This might run a little bit differently. So now it's still plugged in, it's still flashing my little LEDs because the same program is running over and over, because it's still sat in that while loop. While I don't unplug it, keep on doing that same LED sequence. So now I have got the same code as before. I'm just going to compile and run this and press the upload. So hopefully it shouldn't take long to copy across. So we can hear, I'll stop that. So we can hear that it is now running a lot smoother and a lot quicker. I'm hoping the microphone did pick that up. And I might want to play about with these values now. You know, I might actually want to say, let's just go up, oops, wrong program. I might just want to say let's go up in 5s, because this is behaving much better than the Tinkercad thing is. So I could just experiment a little bit. You know, I could say instead of going up in 10s, let's go up in 5s. Let's go up that little bit higher. Let's try 2500. Let's come down in, let's start the 2.5. But we can now play about with how much we drop by. So I could say, yeah, let's come down in 50s, but let's delay it a little bit. Let's delay by 100 milliseconds. And again, this is where you can have a lot of fun with it, making different sound effects. Okay, so now it's copying it across. Okay, and you probably heard that it does hold the note while it's playing the LEDs. So obviously what I should do is put the whole no tone speaker in, and that'll stop it while it's playing. Okay, so I think that's the end of this session. If you found any of this useful, please remember to like and subscribe. Leave any positive comments below or any suggestions for future content. In the next lesson, we'll look at some input, so pressing switches to make things happen, and also some basic servo controls. So hopefully I'll see you in the next one.